Welcome students, in this video where we will try to learn the concept of different types of motions, and along with the learning and the theoretical definitions we will see the practical applications of the chapter or the concepts of the chapter with the help of a teaching aid. And how to make that teaching aid or that model, you can refer to the other video that I have in this channel. So let's begin. So in the very beginning, what we have, what is motion? An object is said to be in motion if it changes its position with respect to its surroundings in given time. It is always seen and measured with a point of reference. All living things show motion, whereas non-living thing means those doesn't have life show motion only when some force is acting on it. So when a force is acted upon, then only non-living things move. Then the major types of motion, they are translatory motion and circular motion. We will see what are they. So translatory motion, the motion in which all points of a moving body moves uniformly along a straight line is called translatory motion. As you can see, a car moving forward, the whole car is moving, an apple is coming down, the whole apple is coming down, not a part of it. So this is translatory motion. Moving forward, here is the teaching aid, and in this teaching aid there is a example of translatory motion here in the middle, that is shown as the rectilinear motion in this portion. So moving forward, how it is acting, we will see. There is a car, the car is moving in the straight line. Similarly, the other car is also moving in the straight line. So this is the whole car is moving, not a part of it is moving. So here these are examples of translatory motion, and since the cars are moving in this model in a straight line, it is also an example of rectilinear motion. Moving forward, rectilinear motion, as we described, if a body moves in a straight line, it is called rectilinear, and if a body moves along a curved path like in hill station or so, then it is said to have a curvilinear motion. Now moving forward, circular motion. An objective is said to be in circular motion when it moves around a fixed point called axis. So there must be a center of it. So in the TLM teaching learning material, we also have an example of circular motion. So let's see how they are working. So in this example of circular motion, we can see a dumbbell-like figure where there are two balls and there is a pin at the middle and it is moving freely upon the axis, that is the pin. So we seen the example of a circular motion in this slide. Now moving forward. Types of circular motions. Circular motions can be of two types, revolution and rotatory motion. So what is revolution? When a body as a whole moves in a circular path, its motion is called revolution, and the body is said to be revolved or revolving body. As we have chairs in our house, we say them revolving chairs. Mainly we see them in the office spaces and so on. Similarly, what is rotatory motion? When a body undergoes translatory motion in such a way that its parts cover different distance in a given time is said to have rotatory motion. Let us see an example of rotatory motion. So here the windmill, as you can see, it is an example of rotatory motion. So let's see, it's walking. So when wind is there, or here we are moving it, so upon the center axis the rotation of the total windmill is happening. So this is a example, you can see a rotatory motion. So the example is a windmill. Now, next type of motion we are seeing in our slides is random motion. Irregular motion of a body in which the direction is not fixed is called a random motion. Now, next, oscillatory motion. When a body moves to and fro about a fixed point is said to be oscillatory motion, like we see in the swings in a park. Similarly, in our teaching learning material, we have tried to make a swing-like structure at the right top corner. So let's see how that is working. So in the swing-like structure, when it is a force is applied, it is having a to and fro motion. So this is an example of oscillatory motion. Moving forward, vibratory motion. Sometimes the whole object doesn't show to and fro motion, but a part of it shows motion. Such a motion is called vibratory motion. The motion is actually a very fast to and fro motion. All musical instruments show vibratory motion. During this motion, a change in shape and size takes place. So, in our teaching aid, there is an example of vibratory motion where a rubber band is fixed between two pillars, and let us see how that is working. So, here in this video, whenever we are unresting the straightened rubber band, then a vibration is being observed. So, here we see the example of a vibratory motion. Next, periodic motion. When the same motion repeats itself after equal interval of time, we call it a periodic motion. As we see in the clocks, there is a definite time when the hands of the clock comes back to its previous situation, like a 12 hours interval, or we say you can say a 24 hours interval also. So similarly, in this teaching aid, we have an example of periodic motion. Here we have made one pendulum. So how a pendulum works? When a pendulum is vibrated, it goes to the end and comes to the center, and again goes to the other end, and it rests coming back to the center position. This is how a pendulum works, and this is obviously a example of a periodic motion, the pendulum. Moving forward, objects actions having more than one type of motion. So in one object, in these cases, we can see multiple motions. So drawing water from well. So this is an example from our daily life. In this case, the pulley on which rope is put has circular motion, and bucket has the linear motion. So the circular pulley has a circular motion, and the bucket that is coming up and down, that has a linear motion. Frisbee. In this, the frisbee has rotational motion as well as the linear motion in the direction of its moves. Similarly, sewing machine, most of us have seen in our houses. Needle of the sewing machine oscillates and the wheel rotates circular. So both oscillatory and circular motion are here. Motion of the earth revolves around the sun, thus showing circular motion, and rotates around the axis, showing rotatory motion. Both the above motions are repeated after a fixed interval of time, so it's periodic motion too. Moving forward to the next example, a bicycle. When a person rides a bicycle, the cycle and the rider shows translatory motion, whereas the wheel shows circulatory motion. Screw. When a screw is screwed into a box, it shows both rectilinear and rotational motions, because it goes down because of a rotational motion, but it goes down straight, so that's a rectilinear motion. Now here we have shown another example of different types of motion, that is a downhill motion. As we can see, there is a slant type of situation, as we see in a slide in a park. Whenever we putting something on that, it is just taking a slide and coming down. So this type of motion we called a downhill motion. As we can see, so this type of motion is a downhill motion. Now here we are recapitulating. So in this model we can see different types of motions. Here we can see 7 types of motion. One is the swing that shows oscillatory motion. There is a dumbbell like structure showing circular motion, where the things is moving in a circular path based on the axis and the center. Then vibratory motion, it's a to and fro motion. This is a rotational motion. Of that, the windmill, when it is covering a round clockwise or anti-clockwise path. Then we have a pendulum describing periodic motion. Lastly, we discussed about downhill motion, and in the middle we can see the cars moving in a straight way describing the rectilinear motion. So here we comes to this chapter. I hope you have enjoyed this class. If any feedback is there, please let us know. For any doubts, please write in the comment section. Thank you so much. Thanks for your patience.